Again, for 34, we have product to a power. So we take our exponents to both things inside the parentheses here. So we have 3 to the 6th power, x to the 7 halves, to the 6th power, x squared to the 6th power. 3 to the 6th power is 3 times 3 times 3 times 3 times 3 times 3, which is 729. If you're not sure, type it in your calculator. Power to a power right here means we're going to multiply those. 7 over 2 times 6. And we're going to multiply our second set as well. 2 times 6. 7 halves times 6 is 21. We can take a 2 out of each of those. 7 times 3 is 21. 2 times 6 is 12. Now we're multiplying powers, same base, so we can combine those as x to the 33rd power. We add our exponents there. Multiplying same base, add our exponents. The 2 goes to all the pieces, and remember here, it's like we have -1 times 5 times g to the 4th power times h to the 6th power. Same thing here. It's like we have g to the 5th power to the 5th power, h to the 5th power to the 5th power. We take those exponents to all the pieces. -1 squared is just +1. 1 times 5 squared is just 25. Power to power means we multiply our exponents there. 4 times 2 is 8. Multiply our exponents here, h to the 12, 6 times 2. Power to a power, we're going to multiply our exponents, g to the 25th power. Power to a power, h to the 25th power. Now, we're multiplying power, same base. So I'm going to add my exponents here, keep my 25, g to the 8 plus 25, h times h. We're multiplying everything here. I have 120 in between there. Okay, 12 plus 25. 25 g to the 33rd power, h to the 37th power. Same idea here. Every factor, which are the things that we multiply together, gets that exponent. So 2 cubed, a to the 5th power cubed, b to the 5th power cubed. We get 3 cubed, a to the 5th power cubed, b cubed, cubed. Each one of those are their own things, so they each get that exponent. 2 cubed is 8. Multiply power, same base. Power to a power means we multiply our exponents. It's a power to a power, exponent on top of each other. Same thing here. 5 times 3 gives me 15. 3 cubed is 27. A to the 15th, multiply those. B to the 9th, we multiply 3 times 3. 8 times 27, 216. A to the 15th plus 15. We add those since we're multiplying powers with the same base. B to the 15 plus 9. 216. A to the 30th. B to the 24th. 37 says, suppose a white dwarf star has a diameter of approximately 1.8083 times 10 to the 3rd kilometers, I think. Let me double check that. 4th, sorry. That's a 4. Use the formula 4 pi r squared to find the approximate surface area of the star. So one thing here we need to remember is that diameter equals 2r. So if we want to plug in for r, our radius is going to be our diameter divided by 2, or 1/2 of our diameter. So 4 pi, For my radius, I'm going to take 1/2 of my diameter, which is 1.8083 times 10 to the 4th, and square it. Take my squared to both pieces here, all three, sorry. 4 pi times 1/2 squared is 1/4 times 1.8083 squared times 10. Power to a power means I multiply those. 4 times the 4th is just 1. So I'm going to have pi times 1.8083 squared times 10 to the 8th. When I take pi times 1.8083 squared, I get 10.27 times 10 to the 8th. Move one spot. So I'm going to end up with, when we move that one, we add 1. So 1.03 times 10 to the 9th. Label surface area means kilometer squared. 1.03 times 10 to the 9th kilometer squared. Suppose a spherical asteroid has a radius of approximately 2.4 times 10 to the 3rd meters. Use the formula 4/3 pi r cubed to find the approximate volume of the asteroid. So here we have 4/3 times pi times radius, and we know that our radius is 2.4 times 10 to the 3rd power, and our radius is cubed. I can take that cubed to both pieces inside my parentheses. When we have a product raised to a power, we take that power to both pieces, which is going to give me 4/3 pi times 2.4 cubed times 10 to the 3rd power cubed. We can multiply our number parts, so I'm going to take and multiply all of our numbers and leave my power there, 10 to the 3rd power to the 3rd power. So for now, I'm just going to take 4/3 times pi times 2.4 raised to the 3rd power. I get 57.906 times 10 power to a power means I'm going to multiply those and get 9. Now, I need to put this in scientific notation. So I move one spot and add 1. From a bigger number to a smaller means I add 1 to my exponent, because to get back to where we started, I have to multiply by an extra 10. So 5.79 times 10 to the 10th power. Label here, since we're talking about volume, is going to be meters cubed. Okay, in number 39, we're starting to divide powers with the same base. And when we divide powers with the same base, we subtract our exponents. 11 minus 2 gives me t to the 9th power. The 9th power. Let me just rewrite that. T to the 9. 11 minus 2 is 9. T to the 9th power. And how this works, or why this works, is because we could rewrite this if we wanted as t to the 11th, move it to the numerator and change our sign, t to the negative 2nd power. Now, since we're multiplying powers with the same base, we add our exponents and we still get to here. So when we divide powers with the same base and subtract, it just saves us one step. Same idea in 40. We take y to the negative 2nd power. Since we're dividing, fraction bar means divide, powers with the same base, we subtract our exponents, which gives me y to the negative 7th power. Again, we want to try and not leave any negatives in our exponents. So because it's negative, I take that whole factor to the denominator, and I just change my exponent sign and make it positive. Put a 1 in my numerator if there's nothing else left. (41), same idea. Q to the 33 over 4 minus 8. Dividing powers, same base, subtract our exponents. Common denominator here is 4. So I have Q to the 33 minus 32 over 4, which gives me Q to the 1/4 power. Q to the 1/4. 42, we're going to do the exact same thing for both pieces. So when I look here, I have my C's and I have D's. So my C's, I can subtract dividing powers, same base. I subtract C to the 9 minus 14. I do the same thing with my D's. D to the negative 7 minus negative 10. And remember, two negatives make a positive. This is going to give me C to the negative 5th power, D to the positive 3rd power. My negative exponent I move to the denominator and make it positive. My D cubed is positive exponent, so it stays right where it's at. I only move it, again, if it's a negative exponent like my C's, and I move it to the opposite part of my fraction and change the sign of my exponent to be positive. So I get D cubed over C to the 5th power. 43. Radio signals travel at a rate of 3 times 10 to the 8th meters per second. How many seconds will it take for a radio signal to travel from a satellite to a surface on the Earth if the satellite is orbiting at a height of 3.6 times 10 to the 7th meters? So we have distance equals rate times time. Very important. Okay, we're looking for how many seconds. So I'm looking for time, which means in order to get time by itself, I can divide by my rate. So distance divided by rate equals time. My distance here, it says, is orbiting at a height. Okay, so my distance is 3.6 times 10 to the 7th meters. And my rate is 3 times 10 to the 8th meters per second. When I divide powers with the same base, I subtract my exponents. I can also divide my number parts here. When I take 3.6 divided by 3, I get 1.2. When I subtract my exponents, I get 7 minus 8, which is going to be 1.2 times 10 to the negative 1st. And we leave it just like that because in scientific notation, that is what our answer is going to be. Label seconds. One number in front of our decimal. It doesn't matter what our exponent is in scientific notation. What matters is that we have the one number in front of our decimal. I'm going to run out of time, so I'm going to leave this one right here, and I'll finish up in one last video.